Welcome to a video on the Pythagorean Theorem and its converse to determine if a triangle is an acute triangle, a right triangle, or an obtuse triangle. We'll also take a look at the triangle inequality to determine if a triangle is even possible given the length of three segments. Let's start by reviewing the Pythagorean Theorem that states that c squared is equal to a squared plus b squared, where c would be the hypotenuse or the longest side, as we see here, and a and b would be the length of the two legs. So if we know the length of these three sides, and c squared is equal to a squared plus b squared, we would have a right triangle. But we can also use the relationship between c squared and the sum of a squared and b squared to determine if we have an acute triangle or an obtuse triangle. Meaning if c squared is less than a squared plus b squared, then we would have an acute triangle. However, to apply this, we do have to remember that c will always be the longest side. So in this case, it looks like this would be c, and these two sides would be a and b. And the last case is if c squared is greater than a squared plus b squared. And if this is the case, then we have an obtuse triangle, meaning that one of the angles would be between 90 and 180 degrees. And again, it looks like this would be side C, and this would be A and B. Before we take a look at some examples of this, we do need to talk about something called the triangle inequality. When we're given the length of three segments, it's not always possible to form a triangle. In order to construct a triangle, the sum of the two shorter sides must be greater than the longest side. And that should make sense because if this was side C and this was side A and side B, if the sum of A and B are not greater than C, these two sides could not reach each other and therefore could not form a triangle. So we do want to make sure that we always check to make sure that A plus B is greater than C to make sure that we can even form a triangle. Again, this would be C. Here we'd have A and B. Okay, let's look at our examples. We want to determine if the lengths represent the sides of an acute, right, or obtuse triangle if a triangle is possible. Let's start off by labeling the longest side C. The two shorter sides would be A and B. Notice that 7 plus 24 is greater than 25, so we can form a triangle. So now we'll go ahead and determine what's the relationship between c squared and a squared plus b squared. This will tell us whether it's an acute, right, or obtuse triangle. So we want to know how these two relate. So we'll leave a little blank there, and then we can fill in whether it's less than, equal to, or greater than when we finish. Since c is 25, we'll have 25 squared, and on the right we'll have 7 squared plus 24 squared. Well, 25 squared is 625, 7 squared is 49, and 24 squared is 576. Well, in this case, we have 625 on the left, and we also have 625 on the right. So this tells us that c squared is equal to a squared plus b squared. Therefore, we have a right triangle. Okay, on number 2, this would be side C. Let's go ahead and call this A and this B. Notice that A plus B, or 5 plus 12, is greater than 16, so we can form a triangle. Let's go ahead and set up the relationship between c squared and a squared plus b squared again. So now we'll have 16 squared on the left, and we'll have 5 squared plus 12 squared on the right. So we'll have 256, and on the right we'll have 25 plus 144. So we'll have 256. This is going to give us what, 169? So what we've discovered is that c squared is greater than a squared plus b squared, and therefore this tells us we have an obtuse triangle. Meaning one of the angles will be an obtuse angle or an angle between 90 and 180 degrees. Let's go and take a look at two more. Again, the process is going to be the same. C is the longest side, A and B are the two shorter sides. Notice that A plus B is greater than 9, so we can form a triangle. So again, let's set it up. C squared on the left, A squared plus B squared on the right. So we'll have 9 squared, and on the right we'll have 6 squared plus 8 squared. So we'll have 81, 36, and 64. And on the right side, 36 plus 64, that's 100. So now we have C squared is less than A squared plus B squared, which means we have an acute triangle. All angles of this triangle will be less than 90 degrees. And let's finish with one more. This would be C, this would be A, this would be B. Again, you can interchange A and B, but C has to be the longest side. And notice in this problem that 3 plus 5 is not greater than 9, so this tells us that no triangle is even possible. So it is important that we check the triangle inequality. So if we applied the Pythagorean theorem and its converse to these three lengths, it would show that it's an obtuse triangle, but in fact it's not, because a triangle is not even possible. Okay, hope you found this video helpful. Thank you for watching.